Hello, Pipeline folks. Welcome to today's The Pipeline Conference event, produced by our parent organization, Digital Production Pipeline Association, DPPA for short. I'm Franz Antonella Benjamin, founder of the Pipeline Conference. Our topic today is the role of R&D in next-gen pipelines. This is our third event in our location-based entertainment series. We have one more event in this series, so save the date for Wednesday, May 27th at 2 p.m. The topic is the future of experiential services. The next event after that will be our Pipeline Day of BOFs, Birds of a Feather, at SIGGRAPH. We're aiming for Monday and a larger room this year. The Pipeline Conference will be in person in September 17th in Vancouver, BC, British Columbia, Canada. So save the date and please join us in Canada. Please join our mailing list to stay up to date on upcoming events. This meeting is recorded and it will be posted on the Pipeline Conference YouTube channel. And I'll post the information for that YouTube channel in our chat. I already told you about our upcoming events, so we're going to take questions in the Q&A channel. Now, I'd like to welcome our executive host, Andrew Lazaro. He is a studio leader and director at LAB at Rockwell Group, the firm's specialized studio dedicated to experience design and integration of emerging technology within the built environment. Welcome, Andrew.
Hello, thank you. Thank you so much. It is an honor to be here. I'm a big fan of this series. As was mentioned, this is the third part of the series. The first was with Will from Industrial Light and Magic. Next was our Node from Moment Factory. I'm very excited about the conversation we're about to have with Jonathan Gagnon, who I'll introduce momentarily. I just want to tell you a little bit about myself, our work, and what we do here at the Lab at Rockwell Group. So I'm going to share my screen for the moment. So as was mentioned in my intro, I'm the studio leader for the lab here at Rockwell Group. Here we're rooted in the principles of hospitality and theater. Rockwell Group is primarily an architectural and planning company and firm focused primarily on high-end hospitality across the world, most famous for having conceived the original Nobu concept and having designed many Nobu restaurants and hotels across the world. My boss, David Rockwell, the founder of the firm, I met working on Broadway together. He is also a Tony Award-winning scenic designer. So that informs all of our processes. And then we're rooted in that idea of care for the audience. Before we decide what anything looks like, we really define how a story unfolds over time, who the audience is, and what world they enter. We use a theatrical process called dramaturgy, where at the beginning of every project, we understand the rules of the world. And again, bring that with care for the audience. From that, we then create playful and captivating experiences meant to transport audiences to new worlds, really aiming to engage their senses and emotions. We really think about it as architecture plus the variable of time. What if architecture could change in the way that a story shifts and changes over time? I'm going to show a brief reel to give a little bit of not just words of what we do, but actually let you see and feel it a little bit. As I mentioned, we are a team of strategy and storytellers. That's where we begin. We have a full creative technology team in our studio where we have creative coders, we have an AV systems team, we have physical design, architectural design, interior design, architecture proper, and we also make our own content through our own variations of content pipelines. So that's a brief little bit about who we are. Um, I just want to talk a little bit about process of our pipeline. So as you saw, we start initially with storyboards and sketches, like a lot of you in film do as well. We try to map out what an entire guest's journey through a space is. But we also work in real-time previs. So we don't just look at things on our laptop or on monitors in the office. Some of our projects we literally model and then show using a virtual production pipeline, but to actually let people understand how a space can live and breathe and change over time. This is a mock-up of a restaurant that we opened in Las Vegas. Here, this is us presenting the work at a conference in Macau. But part of the way that this project works is the entire lighting system of the restaurant is rigged to be real-time reactive, shifting every single day. It's reactive to music, it's reactive to the level of activity in the space, can change color palettes, there's different effects. So in this demo, we're asking the audience to literally make suggestions about what they want to see the space do in terms of the lighting effect. And we pull those color palettes or rhythm in real time through a MIDI control board. Just to show that this is the pre-visit scale. This is what the restaurant actually looked like open in Las Vegas. So this sits inside of the Venetian Hotel and Resort in Las Vegas. It's a Michelin-starred steakhouse, which is really designed to feel like a multi-act theater so that when you enter, you're the star. Um, Pulling from a reference of the logo and sort of pulling from this idea we have in our studio of universality through specificity, pulling emotions we felt thinking about what this restaurant represents, wanted to show how space changes over time. And really how a space changes through a sense of connection. So when you walk in, it feels like this. And then, as I mentioned, through the evening, the color palette, the rhythm of the lighting, all of it shifts over time. So the space itself performs into becoming sort of this ever-changing theater of appetite and atmosphere. So I wanted to show that very briefly, just to give an example of how we're using a VFX pipeline in our work to really introduce what architecture can do and be and how it changes over time. With that said, it is my honor to introduce Jonathan Gagnon. Jonathan has a PhD in computer science. He's an R&D leader in the visual effects industry, currently serving as the director of R&D at PitchBlack, which has studios all across the world. You see that he focuses and harnesses his background in computer graphics and pipeline development, production technology to really shape workflows across a global firm where they're creating incredible pieces of television, surveying projects, bringing that idea of deep technical research into a way of preempting practical needs and what a large scale creative production pipeline needs. So Jonathan, thank you for joining us.
Yay, thanks for the introduction. So I'm gonna share my screen. You see my screen? No. There we go.
There it
All good,
is.
Andrew? Yeah, okay,
Yeah.
cool. All right. Hi, everyone. I'm Jonathan, R&D Director at PitchBlack. Today, I'd like to share something we've been dealing with over the past few years. How do you scale innovation as a studio grows? Not just scaling production, but scaling ideas, research, and engineering practices. Let me start with a bit of context. I began my career in 2007 as a R&D developer, working on virtual fitting technologies for online shopping. At the time, whenever we hit technical limitation, we turned to SIGGRAPH papers for solutions. But we quickly realized something. Reading a paper is easy or not. Implementing it is not. That gap led me to collaborate with a university researcher, and that's really where my journey into R&D started. Then I joined Moko Studio, where I built an R&D department in partnership with a university. We worked on a lot of fluid simulation and procedural techniques, and I completed a master's and started a PhD during that time. During that period, we published several papers, including one on procedural ice simulation and a few on fluid simulation. Later, I joined Folks, which became part of a larger group, PitchBlack, with multiple studios across the world. And that's where things changed significantly. R&D was no longer just about solving isolated problems. It became about scaling across teams, locations, and technologies. We continue publishing, including 2 papers on texturing fluids and a talk at SIGGRAPH on procedural fur. But now within a much larger productive driven environment. And that's really where the question of scaling innovation started. Before going further, let me give you a bit of context on PitchBlack. PitchBlack is an umbrella group of VFX studios, including Folks, El Ranchito, Rising Sun Pictures, and Square One, and historically Fuse. Today, the group spans 14 cities worldwide. Over the past few years, we've been working on unifying the pipeline across these studios. We first merged Folks and Fuse, then successfully integrated El Ranchito, and we are currently working on Rising Sun Pictures. Still a work in progress. Today, the shared pipeline is deployed in 12 cities. And what I'll present today is what we have managed to build so far, scaling that pipeline across those locations. And when you try to scale a pipeline at that level, the nature of the problems completely changes. As the company grows, complexity grows with it. You suddenly have more people, more projects, more locations, and a lot more code. And all of these dimensions interact with each other. Scaling innovation becomes a system problem. So we ask ourselves, what are the core problems we actually need to solve? We identified 4 main challenges: deploying code across multiple locations, managing multiple development teams, handling constant changes in the pipeline ecosystem, and structuring pipeline and research projects. And importantly, we approach these as R&D problems, meaning we formulated hypotheses, we experimented, and we measured outcomes. The first challenge was deployment. We needed to release code across multiple countries, often 24/7. And the key requirement was, of course, the code must be identical everywhere. The solution was GitLab CI/CD. That part is not particularly novel, but the real challenge was organizational. Different teams had different practices. Some had no unit tests, some skipped code reviews. And what we observed was the more flexibility we allowed, the more issues we had. So we made a decision. Same rules for everyone. Code reviews became mandatory. Unit tests became mandatory. And that consistency is what allowed us to scale reliably. So with CI/CD, we managed to scale code across locations, but scaling code is only part of the problem. We also needed to scale people. As projects increased, teams became more dynamic. Developers were constantly moving between projects, and team size kept changing. But we quickly ran into a fundamental problem. As teams grow, communication doesn't scale linearly, it explodes. The number of communication channels grows like this. Here, N is the number of people in the team. What it means is with 5 developers, you have 10 channels. With 10 developers, you have 45. And with 20, you have more than almost 200 channels. So doubling the team size doesn't double complexity. It multiplies it. So the problem is not just team size. It's communication overhead. So instead of growing teams indefinitely, we split them into smaller focus teams. But that created another challenge. Different teams were working in a different way. Pipeline teams were using Kanban. Research team was following a scientific approach with the hypothesis experimented and analysis. And that created friction. But when we looked closer, we realized something important. These are actually the same process. So instead of maintaining two different ways of working, we unified everything under Scrum. And that gave us a shared framework across pipeline teams, engineering teams, and research teams. All follow the same framework. This means developers can switch teams without friction. Team leads can align through a Scrum of Scrums, and the entire organization shares a common language. Standardizing teams help us scale people, but scaling people also means scaling code. And we quickly realized something. More developers does not mean more output. Without a strong design, you don't get parallel work. You get interference. People modify the same system, create unintended dependencies, and step on each other's toes. And at that point, architecture becomes the bottleneck. So the real question became, how do we design systems that can handle constant change? And that's the key part, constant change. Because in a VFX pipeline, the system itself is constantly changing. As the pipeline grows, more tools, more DCCs, more APIs are used. And the system becomes increasingly volatile. And the key problem is we don't control most of these dependencies. Our hypothesis was if we isolate volatility, we can manage change. In theory, we should be able to add a tool or remove a tool without impacting the rest of the system. To achieve this, we relied on solid principles, especially the dependency inversion principle. The principle states that we should always depend on abstractions and not concrete implementations, which means we can change the direction of dependency that we have with all the DCCs and different API, like illustrated here. There is a recent architecture that is a good synthesis of solid principles, and it's called the clean architecture. It's the official architecture that we put in place, especially for the core tools of the pipeline. This approach allowed us to decouple our pipeline from external tools, reverse dependency directions, and significantly reduce the impact of API changes. Architecture became a key enabler for scalability. Here's a concrete example of how to use the dependency inversion principle. Let's take the scenario where we have to publish an Alembic cache. We currently use the MyAPI. But what happens if we decide to change to Houdini API instead? We will need to update the code for publishing the Alembic, and usually in more places than we expected. The solution is to define an interface that represents the capability we need, independent of any DCC. It simply defines the method required for the published Alembic cache to work. Then we define an adapter class that will inherit from that interface. Only the adapter will know about the MyAPI. This way, if we need to use Houdini instead, we just need to create a new adapter class for Houdini. This way, nothing on the layer above needs to change. And we can apply this to every DCC and external APIs. Let me show you a more complete example to make this more concrete. I put it in my personal GitHub under a very, very old username. Let's just say it didn't age well. I built a small tool to list shots from a project and allow renaming a shot with a simple business rule. A shot can only be renamed if the status is not started. What's important here is not the tool itself, it's how it's structured. The same use case works with different data sources. We have in-memory implementations for Shagrid, FChack, Kitsu. And I only had time to only create the real implementation for Shagrid. The business logic doesn't care about the data, where the data comes from. And this is very important because throughout my career, I often heard, we're not going to change the database. And in practice, we almost always do. I've personally gone through 4 migrations to Shagrid. And when you don't have proper abstractions in place, it becomes very challenging and very costly. But this idea goes beyond just the database. The same principles applies everywhere. And on top of that, we can expose the same use case through different interface. Like, for example, on this slide, we have a CLI, a Qt applications, and a web application using the same code underneath. So same logic, different entry points. So we are not just decoupling from DCCs. We are decoupling everything: data, business logic, and interfaces. This is what allowed us to adapt quickly without rewriting the system. And this is critical in a system that is constantly changing, because flexibility is not just about technology. It's about how you structure your code. So architecture helps us manage change, but not all problems are the same. Some are predictable, and some are completely unknown. And that's what led us to structure our work differently. The last challenge was more conceptual. How do we structure all our projects? Because not all projects are the same. We introduced a simple idea, a spectrum based on uncertainty. From known solutions to completely unknown problems. On the left side of the spectrum, with low uncertainty, we have the pipeline tools. This is where we have the setup of new shows, the color pipeline, the support for artists, and workflow optimizations. The output of this kind of projects is tools based on integrated technologies. And we are limited by the release mechanism, the tool scalability, and technical debt. To solve these limitations, we are doing software engineering. Typical projects are everything related to software design, like the solid principles. This is where we are building frameworks for the pipeline TDs, where we take care of the database schema, the deployment strategy that I discussed earlier, and technical debt management. The results are software based on existing technologies and methodologies. When doing software engineering, the limitations we can encounter are related to technology limitations and methodology efficiency. These limitations can be addressed through exploratory development. This is where we start exploring new architectures for the pipeline, new release mechanisms, new method development framework. The limitations we can encounter are normally when there's no existing technologies and no existing papers on that topic. Finally, to solve these limitations, at the other end of the spectrum, with high uncertainty, we have applied research. This is where we do literature review, theoretical limitation analysis, paper implementation, and if we are lucky, scientific publications. The results of these projects is new theoretical approaches. The limitations we have in applied research are the validation with prod and validation by peers. Indeed, what we observed over the years is that without validation, research can be isolated and can take a tangent that is not aligned with the rest of the group. One important realizations we had is that this is not just a spectrum, it's a flow. Applied research feeds exploratory development feeds software engineering, and software engineering feeds pipeline tools. In other words, innovation flows downstream and stability flows back upstream. Pipeline tools are stable because software engineering supports them. Software engineering is efficient because exploratory work reduces risk, and exploratory work is possible because research explores the unknown. So if you remove applied research, the entire system slowly degrades. The system becomes reactive instead of proactive. And that leads to an important conclusion. Applied research is not a luxury. It's the foundations of scalable innovation. But that raises an important question. How do you actually make this happen in a studio? So how do you even start that conversation with management? From our experience, R&D doesn't start as a decision. It starts as a necessity. It begins when existing tools are not enough. Engineering solutions reach their limits, and uncertainty becomes unavoidable. At that point, you are no longer doing standard development. You're doing R&D. The second step is how you position it. R&D should not be presented as a cost. It's an investment in capability. Because the value is not just the final tool. It's the expertise you build, the frameworks you develop, the problems you'll be able to solve in the future. And even if a specific tool is never used in production, the knowledge gain benefits the entire organization. One important challenge when integrating R&D into production is timing. Most of the time, production reach out to R&D when a problem becomes pretty critical. But at that point, it's already too late. Research takes time. Exploration takes time. Building robust tools takes time. So reactive R&D is rarely effective. We need to anticipate problems before they happen. So how do we do that? Well, first, we stay closely connected to production, especially to recurring problems. Problems on the left side of the spectrum: pipeline tools, workflows, artist issues. These are the signals. They tell us where we need to invest. From there, we define what we call technological axes. These are long-term area of investment, like simulation, texturing, pipeline frameworks, and rendering techniques, for example. Over time, we build expertise, reusable frameworks, and production-ready tools. So when a new show arrives with complex requirements, we are ready. And this is not theoretical. This has very concrete impact in production. Let me give you a concrete example. When we were working on fluid simulation, we had a production issue that we couldn't solve with existing tools, where we were at risk of not delivering the shot on time. But because we had already invested in fluid simulation research, we had the expertise ready. We were able to develop a solution in about 3 weeks. And that work actually led us to a paper on procedural snow imprints. Without that prior R&D, this would not have been possible. Let me give you another example, this time with fur. It actually started on the Graveyard Rats episode in Guillermo del Toro's Cabinet of Curiosities. We had to render hundreds of rats, and we simply couldn't do it with our existing tools. It was essentially a production blocker. So we had to develop a completely new approach. And that's where the fur technological axis started. Over time, we refined that approach into a framework, and later on Sonic. That same framework saved a significant amount of time and memory. So it did two things. It unlocked a show that would have been extremely difficult to deliver, and it improved efficiency across future productions. That's the value of building technological axis. And this is exactly why R&D cannot be purely reactive. If we only react, we solve one problem. But if we invest, we solve many future problems. And that's what scaling innovation is really about. So if we step back, if applied research is the foundations of scalable innovation, then innovation itself must be structured. It cannot rely on individual effort or isolated initiatives. It must be designed as a system. That means integrating research into production, not separating it, designing architectures that embrace change, and enforcing consistency across teams and deployment. Because in the end, scaling innovation is not about doing more work. It's about building systems that allow innovations to happen continuously. Innovation does not scale naturally. It must be engineered. Thank you.
Amazing. Thank you. Thank you, Jonathan.
Thanks.
I know when we first spoke, I told you how much I love the idea that innovation must be engineered. And I think that's like such an important insight to have. And the idea that reactivity on any creative level means you're only solving the immediate problem. A lot of how I think about it, and I referenced this earlier, a mentor of mine is the composer Stephen Schwartz, who wrote Wicked, which I know your studios worked on, Wicked for Good. And one of the big things he often talks about is universality through specificity. And so if you start with a specific problem, you're then opening up this knowledge gap, or you're opening up a universal way for people to connect to what you're doing because it's universal. And I think approaching innovation that same way really is in line with what I see you doing. I see a few questions coming in on the chat. One was just if you could elaborate a little bit on the technologies and frameworks employed to establish that consistent environment across all studios.
We use Res under the hood for package management, and we couple that with the CI/CD. So when we do a merge request of a package and it's validated by the CI/CD, it runs all the tests. It's then deployed using all the runners across the world to deploy the same code everywhere. So Res and CI/CD are the main things for that.
And then one question that came in, which I'm going to follow up with another, which is as the company grew from small to large and became global, did you feel key points of inflection, both in terms of shift or like breaking points? Was it 35 people? Was it 100 people? was it 500? Did you feel those points of inflections where things needed to
Yeah,
break or the architecture had to shift?
yeah, definitely. Um, just gonna stop sharing my screen. Oops. Okay. Point of inflection, that's a good one. I would say at the beginning we had one development team that was slowly growing, and I think around 15 developers in one team was too much because I was doing
Mhm.
one-on-one with everyone. I was leading all the stand-up, and it was hard for me to focus on everything. So it's related to the um, the number of channels that I showed earlier. When you have too much channels overhead,
Mhm.
so this is where I start really to invest time on Scrum, reading about everything about the literature. And we created a book club in the team. So we
Mhm.
were reading together everything we can on that topic, and we were challenging each other. So that's how we put in place that framework. And it definitely helped us managing the team and the projects. After that, I would say when we had Mumbai in the team, we had a data center over there, so the consistency of the code was really a challenge because at the beginning we were not using CI/CD for deployment. We
Mhm.
were relying on the cron job that was syncing data across multiple locations, so that was not sustainable. It was hard to also visualize the state of the code across a location. With the CI/CD, we were able to see all the jobs everywhere. So if someone was failing in one locations, it was interface, and we were not deploying anything. So we needed to fix the issues of consistency before shipping new code in every locations.
And then related to that sort of scale question is, someone asked questions about the security of the system. What methodologies do you have to prevent data leaks, SQL injections, or any other attacks? And I
Wow, I
assume
don't
you have
know.
a whole IT team behind that as
Yeah, we
well,
have
but
IT teams, and we have someone that is responsible for security. They did audit us a few times, and is good. So I didn't do anything specific for security, but I think it's managed, and it should be fine.
into the I'm envious because I've long dreamed of you know, carving out specific time for a book club or reading together just so that we're thinking about problems similarly. But the flip side of that someone pointed out in the chat as well is documentation and thinking
Yeah.
about how to carry that knowledge forward downstream in terms of documentation and keeping it both complete and concise. How do you
Yeah.
manage that, or how do you find time to actually make sure the documentation occurs
Uh,
as needed?
I do my best to have good documentation. I think it's a recurring challenge that I've heard about in multiple teams outside of the company. Good
Hmm.
documentation is tough. I think now it's easier with AI. You can really ask AI, can you review that, make it
Hmm.
cleaner, or give a summary. But we use mostly Confluence for that. So we have different Confluence pages on every topic, and we try to keep this as up to date as possible. We also relied on the README files for every repo. So normally, if you look at new code, the README should be clear enough so anybody can jump in, understand
Hmm.
the project. And for big projects, we have like what we call SRS, it's System Requirements and Specification. So that really lists the requirements of the projects, the use cases, and how we're going to solve the project. So these are the three way we use to document, but it's not perfect.
Yeah, cool. Um, One question which often comes to mind when I think about the films Connected to New York, that Charlie Kaufman film with Phil Hoffman in it, but thinking about the rabbit hole that you can easily get sucked into. And one question was, if the studio doesn't have a big dev team, how R&D can turn into a rabbit hole and a given topic can never end or never get usable results out. And is there a
Yeah,
mindset you have to think about specific scopes for R&D in
yeah.
that
Because
scenario?
when I started, we were like three people in the R&D teams, and we were managing also the pipeline. So it was really about looking at production issues and doing explorations when there were no answers. And that's when I started to reach out to university to have help for
Hmm.
students. So when I was working at Moco, I reached out to a professor, and back then I was interested also to do a master. So what I did is I created a program for simulation, fluid simulation, and I hired myself as a student. So I started my master degree on one of
Hmm.
the sub problems that we wanted to solve, and we also added up other students that were doing their master and PhD together. And that leverage is pretty interesting because when you create a project like that with your university, you reach out for grants, and when you have grants, this money is going to the students and the professor. And
Hmm.
basically, when you have one grant program, you can have another one. So every dollar that you put as a company, you're going to receive two other dollars.
Hmm.
And PhD students are not super expensive, unfortunately for them, but it's really not expensive to have multiple master degrees and PhD students working on
Hmm.
your program. The challenge is really like how to manage API uh, agreement with your university because they want to
Yeah,
own everything.
of course.
Uh, and how I manage that is normally the university is really interested in publication. So the deal I made with them is like we keep the code, but the university can publish anything on that topic. So this way they have like a freedom of publications, and the students are happy
Hmm.
because they can graduate thanks to the publications they're gonna have. So that works pretty well.
Yeah, which I also imagine, being able to say we contributed to this approach of creating fur at this scale actually helped this blockbuster fit.
Mhm.
Like there's also the good nature. Of course, that's not the same as being able to publish or put your name on it. But one one question that I think came up was thinking about how it boils down to change management, and
Mhm.
this person brought up that in their experience the technical implementation of change is the easy part, but the cultural part of
Yeah.
that and setting that cultural change as that foundation for success is key, if not considered up front. And just a question came about how you manage that sort of cultural change.
Normally, it's not my responsibility to manage that. I'm really more responsible for the code and the things, but of course, I'm involved in that. And what I experience is like you need to do these changes slowly but continuously. So I cannot say, okay, we're gonna change everything from Scrum to I don't know, waterfall, let's say. And I cannot do this in a week and imposing that. We need to discuss it and do one iteration at a time, testing things together. And yeah, that's really how I manage changes. It's like slowly but surely.
Yeah, I mean, what I found, to speak to anecdotally to my side, is usually people enter this field because they are curious individuals themselves. And
Hmm.
if you build the right culture around questioning, which is inherent to people entering this line of work, I think,
Yeah,
then you help build that cultural element because you're answering shared questions together. And I know a lot of our work is trying to think about how you're changing expectations. And those expectations are not just the end result of what you do, but also, that there's always ways to be working together and always ways to be working together better. And I think a lot of people enter our field with that belief. And I think if you
yeah,
set the right cultural construct around that, people buy in.
yeah, definitely.
Um, One question, and this person apologized for how it almost sounds like an interview question, but I'll admit I'm interested in this as well. At a large scale, how do you prevent disagreements or divergence when it comes to design opinions and making sure that those don't slow down the process?
With a lot of conversations and meeting where we challenge each other. Because, for example, the clean architecture that we put in place as the official one, it took, I would say, 2 years to be like really the one that we use, that the one that people understand. Because despite my best effort at the beginning, people didn't get why it was important. So what
Hmm.
I started to do is really prototyping issues that we have in productions at a smaller scale and showcase, okay, this is what we are facing now. I think this
Hmm.
solutions is really valuable and will save our lives in the future. But even with that, it was pushing people to test and try themselves things that I think was a good idea, but I was also open to new suggestions, and I like to be challenged with it was fine. And like for example, Scrum was not my idea. It was coming from someone in my team that used it in the past, and he thought it was a good approach. So this is where we started to read and create a book club on that topic. So, but yes,
Yeah,
it's a
and
long
as part of
process,
that,
especially with the scale of the team. You cannot do this quickly.
yeah, and I imagine part of that is aligning very clearly on what the goals are and revisiting that so that a disagreement is less about Jonathan and I disagree about an approach,
Yeah,
but
no,
rather like bring it back to the goal to try to remove
yeah,
personal opinion as much as possible towards like what are we trying to achieve.
yeah,
But
exactly.
do you struggle with that at the scale with which your operation exists?
Well, we have more channels and more noise
Of
on this
course.
kind of topic, but I'm a very boring person on that because I really look at the literature and I don't have much opinion on these topics.
Mhm.
I just want to see what's the empirical data that we can have with these approaches. And after that, I just look at okay, what give us the best results to solve the initial problem. And if someone has a better approach, I will just use it. And I'm not that
Yeah.
I don't like to fight against these things. I like to have the good solutions for the problems.
I think we're very similar. It is authentically like whatever the best idea is
Yeah,
wins.
the
And
best ideas.
if
Yeah,
we,
I like
yeah, and
that.
if we weigh three different ideas and one doesn't serve the actual end goal as well, or the overhead is too demanding on the system,
Yeah.
that starts to answer it for you immediately.
Hmm.
Um, see, one question came in balancing near-term production R&D efforts with longer-term
Yep.
research. And I know you spoke a little bit about like the reactive approach to
Yep.
R&D and how that's not as beneficial as like the longer-term investing in knowledge. But but also think about how some R&D, when it's actually beneficial, might be months or years after you
Yep.
actually dive into the topic, and thinking about both that as a competitive advantage perhaps for the
Hmm.
studio and how you get buy-in from above to maintain that work.
So the buy-in from above was really when we show financially it was interesting to do this with the university. So we created the like 10 years ago the fluid simulation access. At the beginning we didn't have anything that we could use, but it's more about the people that you can have in your team that has expertise and also
Mhm.
the framework that you develop. Because even if you don't reach the super uh, like uh, the problems that you want to solve that for the academia, everything that you are building to reach that super deep problem is interesting for production. Like for example, like at the beginning, we started to invest time on like recoding SPH simulator, flip simulator, and early simulator. So doing this, we're able to we understand better how things are going, and that's why when we had this shot where we were getting out of RAMs to simulate all the snow, we were able to really quickly develop something, even if it was a prototype. But with that knowledge, we're able to unlock stuff and really benefit the production. The same thing happened with Fur. We had someone in the
Yeah.
team that was really knowledgeable about rendering, and he managed to, thanks to his experience, expertise on that domain, being able to create a shader that was unlocking the productions for that show. So it's more about the people than the tools, basically.
Yeah. Yeah. Um, let's see. One question came in just um, to that question, actually, about the people rather than the tools, is the composition of your team. What type of skill sets do you have on the team, and how has that evolved over to time? And
Yeah.
not as an interview question, but when you are looking to hire, what are you looking for in individuals to
So
know if they're the
it,
right fit for your team?
it depends on because I have multiple teams, we have like several focus. We have, yes, of course, the pipeline tools, we have the engineering
Hmm.
part, we have exploratory development and research. Um, when it's about research, it's really like having a PhD is good, but we also have someone in the team that has a master, I think. But it depends. We have a really uh, like a very different composition of team. Like we have people that are uh, they have a training in artists. others are engineers. So it's a mix of people. So I'm not looking for specific someone like a profile, but as long as people are interested in challenges and learning new things, normally it works.
I have my own sort of like selfish question, if you will, or like a thing that I know I've been grappling with, which is, I guess the first part of the question is, are you involved in any of the hardware R&D or specifications as well?
Not now, but I've been interested a few years ago about haptic, like things that to simulate things, but
Hmm.
not recently, no hardware.
Yeah. The reason I was asking is because a lot of our stuff is setting up IDF and NDF rooms in large scale buildings and
Hmm.
servers to run content at that scale in real time. And so for us, the global RAM shortage happening right now because of data centers is very much throwing our ability to plan
Yeah.
for projects for a loop. Um, One question that came in, which I'm also very curious about your take, is what your take is on software ownership. Is a
Mm.
proprietary better than a stock or an open source or look dev? Just as a
Uh,
few examples of different things out there, even just ways of thinking about it.
yeah. I know that everything related to academia, it's open source. So every time we publish something, we put it online. We just keep like core tools as it's not strategic. For now, we keep it like hidden, but I would like to have something open source, especially with the recent architecture that we built. I think it's worth having like a public API for these things and really decouple the pipeline tools from the database. Like the code I put on my GitHub yesterday, as an example, uh, I think it's something that needs to be shared online, but we could see a future where we put online this kind of frameworks. I think it's interesting.
Awesome. Any other questions from the Zoom room? I think we've hit all of the questions that have come in. One just came in right as I was saying that, which is, what are the things you see in the future?
uh, I would say more AI, probably. It's a topic that I didn't discuss, but yes, we use the Infinity AI to improve productivity in our team. But it is still really exploratory because we noticed that yes, the developers can push code more quickly, but in the same amount of time, we have much more code to review, and sometimes we feel overwhelmed with the quantity of codes to review. And I've seen the tendency where people are just blindly accepting the code, saying, "Okay, it's passing the test, let's move on." But what I've noticed is that we can sometimes having, let's say, if we just have 10% of the code that is not necessarily as we would like it to be, you just accumulated that 10%. At some point, you're gonna have a tangent where the code that you have is not really what you wanted in the first place, and redirecting that code towards the right directions, it's going to use more tokens and it's going to use more time. So yeah, that's challenging, and I think we're going to have this more and more in our field. So we need to embrace it rather than fight it. So I'm trying to use it as efficiently and in a smart way as I can.
Yeah, for us, I think it's similar. I think we're looking for specifically how to use it, almost like furniture designer Tom Dixon called it legal hallucinogenics, where like we're exploring a thing, and before we put our own human hours or brain power into
Mhm.
it, we can like roughly daydream together quickly. But also, we're very much trying to think about it as like, we're not trying to give it the exciting part about why we come here every day. We're trying to give it the mundane tasks so that we can think
Yeah.
about the exciting problems.
Yeah.
One follow-up question on the rendering dependencies was that they were more referring to external dependencies. So the dependency on Autodesk, is that a healthy dependency or could be any manufacturer is what they're asking.
I'm not sure I understand the questions.
I'm not sure I understand the question either. Michael, if you want to elaborate a little bit.
So for now, the because we use a shotgun, but it's
Mhm.
completely decoupled from the core system, so we don't have direct dependencies toward anything from Autodesk, because we have done so many migrations, different instances. So we wanted to
Yeah.
separate
I mean,
those.
on the architecture side, we are dependent on Autodesk, but the entire industry cannot
Yeah,
escape the dependency that is Autodesk. But
yeah,
we also work very much in other, much more VFX pipelines with our team, including Unreal, just so that we are modeling and texturing outside of that world as well. Though in the architectural BIM world, everything must at some point ladder back up to an Autodesk system.
yeah. But there's a Kitsu that is interesting. I didn't really work with it, but
Mhm.
um, I would like to explore it a little bit.
Okay. Um, oh, okay. A follow-up question was, do you prefer to then stay independent by writing a lot of proprietary tools?
Uh, I think so. I think independence is interesting, but I don't know. I like to have the opportunity. I would like to have the opportunity to write more open source code.
Yeah. And I'll say for our side the same, where like, there are a lot of industry standard dependencies that must exist to operate in the world that we operate in and collaborate with the other studios and teams and firms that we work with. But similarly, we want to open these things up and understand
Yeah.
them on our own, or ideally release as much open source as we can.
I like that how side effects is doing. In Udemy, they managed to really take open source solutions that are very interesting in CG and make sure that they have an implementation. So they managed to really gather a lot of cool stuff within their tool sets, and I think that's a really interesting approach.
Yeah. And I think on that note, we will go ahead and wrap it up. Jonathan, thank
Cool.
you for your presentation, for your time, for
You're
the
welcome.
thinking that you're doing at R&D that not just PitchBlack and your partner studios benefit from, but I think we're all benefiting from this way of thinking. Thank you to the Pipeline Conference for having us. And just want to point out again that when they post this on YouTube, all of the links related to the talk will be posted as well, so that if you want to dive deeper, you're all welcome to.
Cool. Thanks, everybody.
Excellent. Thank you, everybody.
Bye.